So, this is the continuation of the previous class. Here we are going to demonstrate hardware case study for and transient performance of a mixed signal digital current mode control buck converter. So, we will be talking about we have already considered design case study of mixed signal current mode control. We will show experimental load transient as well as reference transient performance. So, again we have discussed mixed signal peak current mode control architecture multiple times, and this is the power stage that we are going to consider. And here we have designed this thing using FPGA. These things are also discussed, and we have also discussed that proportional gain we are going to consider 4.64 and integral gain is 0.4, that will be plugged into the FPGA. And we have also discussed the current sensor gain, ADC resolution, DAC resolution, controller gain and voltage feedback gain. Now, we are using a digital PID controller. So, this is our FPGA the parameter setting, which is nothing but 4.64 and 0.4, and now we are going to show experimental result without feed forward. That means, we are also going to consider with and without feed forward. So, here we are not talking about any load feed forward term. So, here you can see at 3.3 volt input, 1 volt output, we are making a load transient of almost nearly 3 ampere. So, it is changing from 0.07 ampere to roughly 3 ampere load. So, roughly 3 ampere load step, and this is designed based on our criteria, which is FSW by 8, and you can see it is a fast order response that we saw in the last class when we have presented the simulation result. It is sluggish because the current mode control behave like a fast order system. Then if we talk about the reference transient performance, we have seen that it is reasonably good for the reference transient. You can see a slight overshoot is there, and then the response is settling almost in 30 microsecond, 20 to 30 microsecond, which is few cycles, maybe 4-5 cycle here, time period is 5 microsecond. And step down performance is also nice, it is settling in around 30 microsecond with slight undershoot and overshoot for both step down and step up consideration. Now, here we are talking about reference step up transient, the zoom version. So, if you see here, the 1 volt is changing to 1.1 volt if you take the average. So, here we have not tapped the output voltage right across the capacitor, that is why the spikes is coming. Otherwise, the spike will go and you will get a very nice clean waveform. And here, as if this time is to roughly around 30 microseconds. So, settling time is roughly around 30 microsecond, and there is an additional overshoot of around 50 millivolt. Okay. And if you go to step down transient, here to here, you will get around, I would say 40 microsecond is the step down, and an additional undershoot of 50 millivolt undershoot. Okay. So, now load step up transient, we are now changing the 5 volt to 1.8. We have kept the same I would say the load resistance and same PI controller gain, but now the load step here we are making almost like a, you see it is a 2 ampere. So, 1, 2, 4, 5. So, it is like almost load step size nearly about 5 ampere load step size, and undershoot here it is 1.8 volt and the division is 0.5 volt. So, we are getting around 300 millivolt, that means we are getting around roughly around 250 to 300 millivolt undershoot, and the settling time here it is coming to be around settling time again 30 microsecond. And if we take the zoom step down version, then we are getting an overshoot of 200 millivolt overshoot, and settling time will be almost like 30 microsecond. So, this is for the design using. So, it is a sluggish response because we know that current mode control behave like a fast order system, and it is for this gain. Now, the reference step up transient at 5 volt, now it is even better response. We are changing from 1.8 volt to 1.9 volt. So, it is coming, and there is almost very negligible undershoot, overshoot, extra overshoot, and the recovery time is coming around 25 microsecond, 25 to 30 microsecond. And if you step down transient, if you see the undershoot is insignificant, so it is 1.9 volt to 1.8 volt, and it is coming around 30 microsecond. So it is a pretty fast transient response for reference step up and step down transient performance. So in summary, we have discussed the mixed signal design case study with current mode control, and we have discussed the load transient performance, and we have discussed the experimental reference transient performance also. So in the subsequent lecture, we are going to see the effect of load current feed forward. That's it for today. Thank you very much.